This is Quadratic Functions, Part 5, Points of Intersection. The points of intersection are where the graphs cross over each other. So we have a point of intersection here and here. The intersecting points of two functions can often be found by solving a quadratic equation. Example 1. Where does the graph of y equals x squared plus 5x plus 4 cross the graph of y equals negative x, take away 1? Normally we're not given the graph to look at, so we have to use algebra to solve this. The y values at both of these points are the same for both functions, and since we have two functions that are equal to y, we can make the functions equal to each other. So we say the y equal to the y, which means x squared plus 5x plus 4 is equal to negative x, take away 1. Now, that's a quadratic equation because we've got a squared x in it, and we need to always solve a quadratic equation by making the right hand side equal to 0. So here we need to add x and add 1 to both sides. Now we've got it equal to 0. Then we need to factorise, and solving that, we get x equals negative 5 and x equals negative 1. Now these are the x values of the points of intersection. We want to get the y values as well. So to get the y coordinates, we sub x equals negative 5 and x equals negative 1 into the easier one of the two, which is y equals negative x, take away 1. It works for both. Substituting them in, negative of negative 5, so that's plus 5, take away 1 is 4, and negative of negative 1 is plus 1, take away 1 is 0. So that gives us the points of intersection of negative 5, 4, and negative 1, 0. Example 2. Where do the graphs of y equals x squared minus 2x minus 8 and y equals x squared plus 2x plus 4 intersect? Again, we make the y equal to the y. So, first function equal to the second function. We again want to solve this, but you'll notice that if we take away x squared from both sides, we no longer have any x squareds. So now we're dealing with a linear equation instead of a quadratic equation. So using balancing, taking the x's to one side and the numbers to the other, we get our answer of x equals negative 3. Substituting x equals negative 3 into either of the two functions, I've just chosen the one with the positives in it. We get the answer 7, and therefore the point of intersection is negative 3, 7, as we can see on this graph.